Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about how to properly override the toString method. I'm going to open up my web browser to my website, javacjava.com, and select Begin. I'm going to scroll all the way down here to my override toString method tutorial. Now throughout my tutorials I've discussed the toString method on numerous occasions, so I thought it'd be a good idea to give this popular method its own tutorial. Now, out of the 11 methods in the object class, toString is perhaps the easiest method to understand. Of course, every class inherits the toString method from the object class, and by default it returns a string value that represents the instance in a stringy sort of way. Now, in order to understand precisely what the result of the default toString method returns, you should first watch my tutorials on object, getClass, and class common methods tutorial, and my overriding the hashCode method tutorials. Both of these will go into some stuff here on that. So, not necessarily 100% required, but if you want a thorough understanding, then I highly recommend those first. But let's just consider the following codes. We got this class here, this empty class, blah, right? And class tester with the main method entry point. And then on this first statement here, I'm invoking the printline method. I'm just passing it a new instance of blah right here, right? And then on the next one, I'm passing a new instance of blah, and then I'm invoking the toString method right off that new instance. Now the result of the above code will produce something like blah at, and then this hex value here, and your hex values will vary, and then it'll produce it twice. Okay, each result is the default stringy sort of description of the object instance. Notice how the first call to the printline method did not explicitly invoke the toString method, right up here. It's just this. That is because whenever you pass just an object to the printline method, the toString method is invoked implicitly, okay? So there's no difference between this or this, all right? It'll go ahead and invoke the toString. It's just doing it, implicitly here instead of us explicitly putting it right here. Okay, overriding the toString method is a very simple process. Simply add the following code into the blah class, right? First thing you want to do is put the @override annotation. It's a good practice in case you misspell or you forget a modifier, or even if you do the return type wrong. So, but basically, the declaration is easy: public string return type toString with no parameters. And then in the method body, you simply want to return a string value. Okay. Now the result will be whatever you want when the toString method is invoked. But the real purpose of the toString method is to return something useful. Now generally speaking, the most useful result from invoking the toString method is to display the current state or instance variable values or value. And I need a line break right there. But anyway, so now I've modified the class blah. Sorry about the indentation issue there, and I've added this private int age 41 and private boolean interesting false. So here we've got a couple instance variables, age and interesting. And in the public overriding the toString method here, I'm going to return the string little age equals plus age, which is our instance variable. Notice it's private, it's well encapsulated. And then plus the string literal, right, comma interesting equals, and then plus interesting. Now the result will be age equals 41, interesting equals false when the toString method is invoked. The toString method is used quite often for simply displaying the current state, especially when private variables are involved, right? We're talking proper encapsulation there. One final point to emphasize: should you, as a programmer, ever try to parse out the result of the toString method to read values that otherwise may not be accessible? That answer is a resounding bad idea. Now, the toString method should never be relied upon for parsing instance variable values. There's no guarantee that future releases of a class will return the string result in the same format. That is the purpose of getter and setter methods, not toString. The toString method is only meant to be informative, not drive logic or change variables. Now let's dig a little deeper into the toString method in the source code below. All right, I'm left a lot out because I'm just going to add it in the video as we go. Highlight this, Control-C to copy, or right-click and select copy. I'm going to move my web browser off screen. I've got a shortcut to the command prompt on my desktop, but if you don't, you create one really fast by right-clicking, selecting New Shortcut, CMD, Next, and Finish. It's just that easy. If you're new to my tutorials, when you first open this up, type in javac, which is a Java compiler command. You should see all this stuff scroll by. However, if you receive an error message, watch my tutorial on installing the Java Development Kit. And make sure you get that installed and configured properly before continuing. CLS to clear the screen, CD space / CD is short for change directory, / tells it to go to the root. I'm going to make a directory here called Java using the MD command. I already have that folder, but if you don't, it'll go ahead and create one for you. Alright, and I'm going to make another directory here, and I'm just going to call this override toString. That sounds good. And change directories to the override toString folder using the cd command. I'm going to notepad up override toString.java, right? That's going to be the name of our source code file, also known as a compilation unit. Control V to, let's paste this in here, and let's just come up here and save this. Let's clear our screen. Let's compile it, and let's run it without even looking at it, right? Okay. Now let's talk about what's going on here, right? Very simple. I got this empty class blah, and then I got this class override toString with the main method entry point. And I am simply displaying to the console a new instance of blah and then invoking the default toString method. Now the default toString method there is because basically it implicitly extends object, right? We can throw this in here, and that will change absolutely nothing. Very similar. What we'll do, oops, wait, I'm just going to, above this one here, show you that it also implicitly calls the toString method when we do that. All right, so now we're going to see this displayed twice to the console. So let's go ahead and compile this. Oops, don't want to compile the class, the Java file. And there we go. All right, so now it's displayed twice, two separate instances, as you can see, because the hex values are different now. And watch my tutorial on hashCode if you want to understand what these values actually represent. I'll go through that just a little deeper here in just a second there, okay? So we implicitly extend object, and we implicitly invoke the toString method right here. All right, so that's fairly simple there. All right, so I'm just going to go ahead and take this out here, and now let's go ahead and properly override this. So I'm going to use @override, right, or annotation, public. I'm going to do public int toString, right, just to show you the value of that. Let's say, for example, we weren't sure about this, or this is just, I'm forcing this into a really stupid situation that wouldn't normally occur there, right? As a matter of fact, you know what? Let's just do this. Let's say string builder, right? Whatever. All right, so let's come up here and save this and see what the @override does for us, this annotation does for us here. So let's clear our screen. We're going to try to recompile this here, right? And we're going to get our error, right? Blah cannot override toString, right? Return type string builder is not compatible with string. So the override saved us here, right? Now let's say, for example, we didn't have the override there, right? Let's say this right here, right? Without the @override annotation, right? Everything is going to compile. Oops, clear string. Well, actually, it won't compile there because basically we have the same parameter here, right? Let's just put in something like, for example, string ASDF, right? Okay. Let's clear our screen. We have the same number of arguments on that, so it isn't going to allow that. Let's clear our screen. So we could recompile that, and then if we run this again, right, we're going to go back to our old default method there, right? Whereas if we throw in, like, for example, the @override annotation here, if this method with this signature here, right, this is the method signature here, if this doesn't exist in the superclass, it's gonna tell us, right? It's saying method does not override or implement a method from a supertype, add override, right? So this kind of prevents throwing in the add override annotation. Is very important to make sure, you know, if you don't have any typos or anything like that, right? So let's come up here, let's save this, let's fix it real quick. All right, we're all good there. We run it again, bada boom, bada bing. Let's say, for example, I had a mistypo here, right? We come up here, we save this again, and clear our screen. And the, oh, man, wait, this didn't want a typo there. String, I wanted a typo here. Right, if we have a typo in our name there, right? The add override method is going to protect us. Method does not override or implement a method from the supertype, right? Without that add override in there, if we almost had the toString overridden here, right? Let's clear our screen on this. It'll go ahead and compile, and then when we run it, right, it will go ahead and produce the blah at blah blah, right? So we didn't override it at all because we have just a little typo here. Okay, so always important to do that. All right, I promise I'm moving on now. All right. So let's go ahead and just put in age equals 41, string name equals, and let's do like Billy, right? That sounds good to me. All right, so this is really what it's kind of meant for. We're going to make both of these private there, so they're not accessible from the outside there. All right, so we're just going to return comma and name equals. If I could type today, that would sure help. Plus name. All right, let's see. All right, let's compile this and let's run it now. So now we get age equals 41, name equals Billy. So that's kind of really what the purpose of toString is there, is to, you know, kind of show you just an informative thing on what the instance variables are on that. So let's now talk about this up here, blah at this number right there. How does that actually come into play there? Well, let's go ahead and override our toString method to actually return the various different things there. All right, so in the object class, there is a method called getClass, right? And getClass, what we're going to do is we're actually going to, the getClass method will return a class object. Now that class object, and when I say class, I'm talking in uppercase C, and yes, there is a class named class, right? So if that's not confusing enough, but in that class, uppercase class, there is a method called getName, right? And that will return the current class instance name. So let's just go ahead and come up here and save this. Okay, so now we've got our blah down here, which is that first portion of it up there. All right, now let's talk about the hashCode. Okay, so I'm just going to do this, and then plus we inherit the hashCode method, so we can directly invoke the hashCode method like that. I'm just going to save that, right? Let's clear our screen, and let's run this, right? And we get this number right here. I'm just going to I'm gonna take my add override out right now because I'm just going to misspell this here, right? I'm going to save this, right? And just so we can see this, right? So this number is not the same as that, all right? So how do we get this hex number? Because this is an int value, by the way. Hashcode returns back a primitive int value. So what they do is they actually, we'll go ahead and put this back to toString, so we're writing that. They use the integer class, and they invoke the toHex string method, which takes a integer parameter and converts it to a hex string, okay? So let's come down here and save this, and let's recompile, and there we go. All right, so there's the 2A139A55. And watch my tutorial on the hashCode thing if you want a little bit more information on how it gets it. You know, basically, well, it goes into a lot more detail on that. I won't bore you with the details of hashCode. You can do that in the hashCode method tutorial there. All right, so let's just go ahead and put all this together now. And here's what we get. So we're going to do getClass.getName, right? Plus, and then an @ symbol, and then that. All right, so there we go. Now we've overridden the toString method with exactly what the original toString method basically consisted of. So let's compile this and run it. And then there we go, blah at, you know, and so on and so forth there. So that is kind of the guts of what the default toString method actually returns, in case you're curious on that. All right, I'm gonna go ahead and get rid of this and get rid of that. And basically, you know, I've covered everything I want to on the tutorials there, you know, how to properly override it, what its purpose is, what not to do as far as like trying to parse results out of the toString, and then what the default toString method actually, how it actually works and how it's actually made. So anyway, that concludes this tutorial. Thanks for watching.